here real quick. This one, the graph would be, so this is a displacement time graph. If you're describing the motion, this is constant positive velocity. This is zero velocity. That's all you would have needed to say. You didn't need to get into, oh, this animal's doing this, or this roller skater is doing this. It's just tell me what's going on. Velocity, constant positive. Velocity here is zero. When you've got multiple chunks, so like I've got an A, a B, a C, and a D here, A, B, and D all have constant positive velocities because all of the slopes there are up and to the right and not flat. C is not moving because its position's not changing. But A, B, and D, yes, they're all constant positive velocities, but in a description of the motion, we can do better than that. Because the steeper the line, the faster the object. We don't necessarily know what these values are, but we know how they are relative to each other. So A is constant positive V, and it's the slowest of the three. B is constant positive velocity, and it's the fastest. D is constant positive velocity, and it's the middle speed of the three that are moving. Was there a hand that I saw that went up there a second ago? No, it was Emma just playing with your hair. Okay, cool. Questions about either of these? Okay, moving on. Brad, put your music away. You can listen to music while you're working on work. 4, beside the graph, describe the motions represented by each of the graphs. If the speed is changing, describe whether it's increasing or decreasing. This is an increasing positive velocity. It's getting steeper as it moves in a positive direction. This is a decreasing positive velocity. It's still moving in a positive direction, like displacement's increasing positively, but the steepness is decreasing. It's getting shallower. So it's slowing down. So it's positive, decreasing velocity.
Why is it positive decreasing? Oh wait.
Because the position is getting more and more positive, but the slope is getting shallower. So if the slope's getting shallower, it means the velocity is decreasing, but because the position is positive, it's still moving positively. This is a positive decreasing V. This guy here, you could see this as kind of curved up, or you could see it as flat. I don't know. I think it's curved up. So this section is going to be positive increasing into positive decreasing. So it's positive and going up. Here it's still positive and decreasing. The V's are. Comments, questions, concerns about any of those? Okay, if you missed the lesson and you have no idea what's going on, the videos are up, or I can help you with this during tutorial tomorrow. I should have answers to these somewhere. Describing the motion here. Constant positive, not moving, constant negative. Effectively what's happened here is object went out, stayed for a while, went back to where it started. Yes, Emma? What's your example? Well, if you can't read it, I can't read it, and I wouldn't take it. But yeah, sorry, the short answer to your question is yes. Okay. If you gave me an object that was, he started at the super lab, he walked to the water fountain, he took a drink, he turned around and returned to the super lab, totally acceptable. Okay. Yes. More detail than you have to give, but yes, that would be an accurate understanding of that picture. This one started, so, and I can act these out for you, maybe it helps. You can put words to it at that point. I'm here at 0. The second one, actually, I don't even need to hold it. I can put it on the screen and I can show it to you that way. So here I am at 0. I walk out constant positive, and then I go back a little ways, and I go forward a little bit ways, and I need to go back a little bit ways, and then I stop. I don't make it all the way back to where I started. I just would have needed to go back and forth as many times as there are strikes. So it's constant positive velocity, then negative. Like, and there is no stopping and waiting for a little while. It's immediate change in direction, immediate change in direction, and immediate change in direction, and then not quite making it back to where we started from. The last one is more like what you would actually see in the world. I'm starting here next to Lachlan. He's going out, I'm getting faster, I slow down, and then I go backwards, I speed up, and I slow down. That would be the law. Increasing, decreasing, and then it's a turnaround up at the top. Increasing negatively, and then decreasing negatively. The slope is down. That's what that one would look like. And then for question 6, if you did question 6 and you found all the tangents and you don't have any questions about it, 6 looks like this. 6A, all of us should have the exact same-ish values for 6B. 2.5, 0. I got 1.875 from 14 to 18. 14's there. 18's here. 14, you're ballparking that, depending on what you call this. I called it 12.5 to 18 seconds is right there. That's going to be at 20. And then 6 to 17 seconds, is I got 0.91. 6, there he is at 5. At 17 seconds, he's at 15. So 10 over the 11 seconds is whether you call that 0.90 repeating or 0.91. Either of them are acceptable. Where it gets really interesting are these bottom ones. Find the instantaneous V at a bunch of different places. These were my tangent line values. As long as you are in the ballpark, this one was 2.5, 1.8, 2.14, and 1.8. You just need to be close-ish. Kai.
Yeah, what is close-ish? Like,
what did you get? What are you comparing?
A couple of them I got off 2 meters.
So, what did you get for 1?
3.75.
Okay, what did you get for 2?
1.6 repeating.
Okay, that's really close. What did you get for 3? What do you need?
13 seconds I got.
Yes, sorry. Next block?
Next block.
Okay, next block's my prep. As soon as these guys are gone, I'll bring them over.
Awesome.
I was planning on putting this all the way then anyway. In the lab or in your room?
In the lab.
Perfect, it'll be back. What'd you get for 3?
0.5 meters per second.
Okay, that one definitely is going to be a problem. For the 13 seconds, you got 0.5? Yeah, that's going to be a problem. And then 4?
3.75 meters per second.
That one sounds problematic as well.
Yeah.
I would have to look at how you drew your tangent lines and what you did there to know. But my gut says that you probably did 1 and 4 correctly. You just need some practice with tangent lines. Your value for 3 sounds a little bit bigger of an issue. But I'd have to look at each one individually. Emma. Were you away yesterday? You were here when I did it? Okay. Yes, let's do it, happily. I'll do one of the ones I haven't done already. So, Kai, which one was your 13 seconds? That was your worst one?
Yeah.
Okay. So let's take a look at the 13-second one. To do an instantaneous velocity, you guys my goal here is that you guys practice and start to get a handle on what it meant to draw a tangent line. Now, a tangent line needs to touch the graph at one spot locally. So 13 seconds is going to be right between 12 and 14. So that point right there. So you want to draw, I'm putting my pen down, and you want to kind of rock your ruler around the pen to kind of best, I'll go to the edge of the line, to kind of best approximate come on, you stupid thing, what the curve is doing at that point. So for 13, I would probably do a line that looked like that.
Mine looks pretty similar, I think.
You know what? And maybe I'm going to get a different value than I got before. Who knows? We'll find out real quick. Okay, so that's going to be my tangent line. I probably could have made it a little bit steeper, but I think that's good. And now what we want to do is we want to find the slope of that tangent line. So I want to find places where that line goes through the grid at places where I can confidently say what the value is. For example, this point right here is pretty good. It almost exactly goes through that point. So I'm going to use that one there. And then I'm going to use that guy right there. So this point right here is the point 20, 25. And this point right here is the point 6, 0. So if I'm going to find, oops, sorry, I'll zoom out a little bit. So if I'm going to find the slope of the velocity at that point, I need to find, sorry, if I'm going to find the slope of the tangent at that point, I need to find the slope using these. So y2 minus y1, or you can just count. The rise goes from 0 to 25. So that's going to be a rise of 25 over, and then the run goes from 6 to 20. That's a run of 14. So then that's my rise, that's my run. I'm going to do the division here, and I sure hope I'm close. 25 over 14 is, oh, look at that, 1.79. So this value was from about 4 or 5 years ago when I did it the first time. This is the value that I got today. They're not the same, but they're very close. 1.875 meters per second or 1.79 meters per second. That's effectively a difference of 12 centimeters traveled per second. Not a lot. Yeah, Kai?
I thought you should compare that to the 13 seconds. That's wrong.
What do you mean? Sorry. So you're right, worse. But not terrible. Not 0.5. You're right, I'm comparing it to the wrong thing. Sorry, Emma, you've started talking twice and I interrupted you both times. But Kai, you're right. Yeah. Yeah. It's the same thing I did. I mean, I counted it instead, but it would be 25 minus 0 and then 20 minus 6. 25 minus 0 is 25. You're right, Kai, I was putting that in the wrong spot. 25 minus 0 is 0, or is 25. 20 minus 6 is 14. So 2.14 versus 1.8. You're right, not nearly as close as it was, but still big difference between what you got and what I got. Does the process make sense, Emma? And Kai, that's the biggest issue, the process, which is why if you got something radically different, I'd want to see what you did here for the tangent line. And it is going to take practice. I wanted you to do 4 of these. You guys are going to do a lab for me, and you're going to do 5 more.
I think my line could have been more slope. So
and this is a hard one to do it with. So it's just getting you guys a handle on practicing that. Questions, comments, concerns? Going once, twice, thrice, sold. Okay, cool. Then here's the answers to the questions on the next page. You can take the answers down, compare them with what you got. 720 seconds, 26.74 kilometers per second. Either 21,600 meters or 21.6 kilometers. 27.78 meters or 28 meters. And 0.36 seconds. Buddy's getting crushed. Yeah.
Number 4, is it asking how far you'll travel 1 second going 100 kilometers? Because it's saying that you're braking, so I'm assuming you're going to be slow.
No, it says that it takes you 1 second to apply the brake.
Oh.
In the time it takes you to apply the brake, how far have you gone? Yes, Alana. That's 303 days. So that the Viking one, the first spacecraft to land on Mars, traveled 7 times 10 to the 8 kilometers in 303 days. So you'd convert days to seconds and then do the division. So it's going 26.74 kilometers per second. So that's like Mount Lehman to 264th Street every second. That spacecraft is huffing it. Okay, flip the page. These are the answers to these guys. And again, yes, I'm giving you the answers, but you still need to know how to do this stuff. Even if you didn't get it down, I want you to take the time to go do it. Otherwise, you're not going to learn it. The answers to 7 is there. 7B is yes. You had to graph 7 in order to correctly do this one. And then question 8 was a bit of a yes, Kai.
When do you think our next unit test is going to be?
When we're done. I don't know.
No estimations?
Yeah, nothing for you.
Or...
Well, beginning of April, almost certainly. I don't think we're going to get the unit done before spring break.
Okay, I thought we were like pretty deep in the unit.
We are. We are pretty deep in the unit, but we've only got 11 days between now and the break. I mean, in a perfect world, I would assess you. We've got a bunch of labs that we're going to do too. We've got 2 or 3 labs that we're going to get you guys to do. First one of those is going to be tomorrow. So because of those labs, it's going to push everything back. And that was the last one, question 8. 8 is very similar to word problems you would do in math class in a grade 10 class, depending on whether your teacher made you do them or not. 8 is not. 8 is probably worse than anything I would ask you to do on a test or a quiz. But there it is. How much time passes? 24 minutes. So if you can get a chance to play with them, don't ask questions, play with them, and then ask questions. Is there anything anyone who did attempt them would like me to do? Going once, twice, thrice, sold. Okay. So, I lied to you just now, Kai. You guys want to do a lab for me, right? So, here you go. You know what? Actually, I'm going to do this. Come grab.
I grabbed it last.
Get up, go get a handout.
I grabbed it just. You grabbed everybody.
While you're doing that, I'm going to go get you guys some toy trucks.
Oh, you did. I think Caleb should go still. I already grabbed. I grabbed the folder. Remember all the times I got you the folder? You're right there, buddy. You're right there. No, I'm not. You're at least 2 steps closer than I am. Oh, God, that's crazy. God, that's crazy. This is 4. So it was like 10 times bigger. No, it's like, why is it so big? Mind you, I have good cardio. Yo, that's outrageous, man. That's crazy. Yeah, sorry, actually sort of red. Yo, this guy said that word like 8 times. I mean, if you play like 3 single games, 21 points, and like it's really close each game, you're trying your hardest to take any breaks. Yeah, it'll be like fucking exhausting. But you play no. I'd probably be sore the day after, maybe the second day. But this one, I put the friends last night. I don't talk about it.
Here we go. Yes. You're going to be working in 2s or 3s for this. Don't worry, if your truck has a name, don't worry about it. Here is what you're doing. Toy Truck Velocity Lab. It's stuff that we've done before, but it's a practical exercise in this, which you guys are going to do. is you're going to determine the relationship for between displacement and velocity for these two trucks. You're going to get two of them, a blue one and a red one. The blue ones go like this. Very, very slowly. The red ones, much quicker. What you guys are going to do, you were using a stopwatch, or all of you have timers on your phones. You're going to get some masking tape from me and a couple meter sticks. Meter sticks are over here. The masking tape is over here as well. Here's what you guys are going to do. You're going to mark out half-meter intervals for 4 meters on the floor. You'll have time to get all of this done, so before class ends, at least the data taking portion of it. So you can go into the hallway if you'd like. You can work in the space between Mr. DeVries' room and myself. You guys need to figure out a way to conveniently mark out half-meter intervals down the floor for 4 meters. You're going to measure the time it takes each truck, the red and the blue, one at a time, to reach each interval. And you're going to record the data in the table. Now, there's a few ways you can do this. The way I've set these tables up here's how I've set these things up. So you're going to have like 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5. And actually, that should have been 4 because the first one's going to be 0, 0, 0. So actually, we really should have started at 0.5. The way I've set this up is that for those of you who are familiar with your stopwatch, you know that it has a lap function. Rather than stopping each time to read out and then write the time, because especially for the red truck, it's a little bit quicker as it passes the half-meter marks. What you can do is you can start your stopwatch, and then as the truck passes one of the pieces of tape, you hit the lap. It'll record the time it took for that first chunk. Then you can hit lap again. Every time the truck hits the next piece of tape, you can hit lap. And then what you're going to get, this is the total time. But what you'll get down here is you'll get times for each segment. If you choose to do it this way, that's why I've set the table up this way. If you choose to do it this way, what you need to make sure that you do is that as you record these lap times, maybe 5.41, 4.06, 2.01, 1.74, 1.79. These are the individual lap times that I recorded on my phone. The total time is always going to be the sum of the previous lap times. So the total time at the half-meter mark, that's going to be your 5.41, because 5.41 plus 0 is 5.41. The total time for the 1 meter mark would be the sum of these 3 for this one. This one would be the sum of these 4, these 5, these 6, etc., etc. The reason I put this middle one in here just so it would give you guys, and it makes it a little bit easier to record the time data. You're going to measure out the time it takes the trucks to reach each interval, and then you're going to graph that data. You're going to construct the displacement versus time graph of each truck's motion. Both sets of data need to be on the same graph, and you're going to do it both by hand and on a computer, which you'll have time to work on this lab tomorrow. Use 2 different colors to differentiate the 2 trucks. How you choose to assign colors to the trucks are up to you. I've had students who decided they wanted to be difficult, and they put the data for the red truck, they made that line blue on their graph, and then for the the blue truck, they made that data red, just to be difficult. If you need colors, I have colors. I have a whole box of pencil crayons for you to use. If you have colors of your own, differentiate between the red and the blue truck. If you're not using red and blue, or you're using red and blue in a silly way, make a legend so that I can tell which is which, or actually label them on your graph. You're going to find the slope and the equation of the line based on your data. Do not use y equals x for your equation. Instead, use the variables applicable to the lab. Using two non-data points, this work should be done right at calculate your slope right on the graph you made by hand. Then, what you're going to do, part 3, you're going to make a graph for this data using either Excel or Google Sheets or Desmos if you'd like. I made this before Desmos was a thing. You could use Desmos if you like. Give the equations of the trend lines like we did in that lab assignment from about 2 weeks ago for the red truck and for the blue truck, and then you're going to compare the motions of the two. I want you to print off this computer-generated graph and include it as part of your lab handout. Conclusion 1, describe, compare, what do the slopes of the graphs represent, compare your hand-done graph to the computer-generated graph, how do the equations compare. You'll see that, I'm hoping that you will see that a line done as a line of best fit versus what the computer tells you for the same set of data is close. And then comment on any weirdness in the data. You may have error. Someone may have screwed up somewhere. Maybe someone yelled at you when you looked up and then the truck was passed. And then you're like, oh, maybe it was this. Whatever weirdness showed up, talk about it. Why is it there? What could have caused it? What would you do different to help next time to prevent it? This is a discussion of error. What went wrong? Staple both your handmade graph, your digital graph to the back of the page. I've included graph paper for your hand-done graph. This is what we're going to spend today, tomorrow doing. Comments, questions, concerns. Find yourself a partner. You will need one of each truck. Mark out your 4 meters in half-meter intervals along the floor. If you do it in the classroom and you don't get it finished, you can leave the tape on the floor until tomorrow. But if you go into the hallway and do it up there, then you're going to do enough before you go. All of your displacement columns should look exactly the same, yes. Because it's the distance from where you carry along in the lab. Okay. On your mark, second. Yeah, we know. There you go. You can do it in 2s or 3s, yes. Not alone. 2s or 3s. The meter sticks are over here, so is the tape. Get what you need.
Just say yes, and then they would have
Okay.